Hello, my dear students of class 10th. All of you must be very busy studying science. लग रहा है कभी केमिस्ट्री पढ़ लें तो कभी फिजिक्स पढ़ लें तो कभी बायो. If you are still struggling to complete your physics, chemistry or bio, here is a video for you. So today's video is on all the important topics and questions of physics. So I am going to cover all the chapter one after another of physics, and for each chapter I am going to tell you which are the most important topics for you to focus on. I'll also tell you some sample questions, but this time I am not going to give solutions for all the questions because I want you to learn all these important topics and give these questions a try. However, if you need the solutions, the link to the solutions would be given in the description section of the video. Light, reflection and refraction is one of the most important topic for class 10th physics. Roughly the weightage of this lesson is 7 to 8 marks. In this lesson, ray diagrams are very important, as in image formation by lenses as well as image formation by spherical mirrors. Both are equally important. You may get derivations, you may get numericals based on ray diagrams. So please be clear with them and do not try to memorize the ray diagrams. That would be a disaster. So understand the ray diagrams and you will be able to answer most of the questions related to spherical mirrors and spherical lens. Mirror formula, lens formula and power of a lens. These are three such topics from where you tend to get more numericals, and these are mostly formula based numericals. Pretty simple and straightforward. Refraction of light is another important area from where you get more theory related questions. For example, you may get logical questions like how is a rainbow formed, or why is the color of the sky blue, or what's the reason behind twinkling of stars. So these kind of short answer questions can be expected. Besides that, many a times you get a one marker question from the applications of spherical mirrors, as in which type of mirror is used in the rear view mirror of your vehicle, or which mirror is used in the shaving mirror. So these kind of questions can also be expected. So now is the time to look at some of the sample questions. Question number 1. In the image formed by a mirror, for all positions of the object placed in front of it is always diminished, erect and virtual. State the type of the mirror and also draw a ray diagram to justify your answer. Write one use of such mirrors are put to and why. Okay, so here these are the three most important words that we need to focus on. Whenever we have questions related to image formation by mirrors, we should be very clear in our mind with the ray diagrams. So just think, which is that mirror? Because we just have options for two mirror, concave mirror and convex mirror, right? Now, it's very simple to remember that in case of concave mirror, we get both types of images. For example, when the object is far away, we get real and inverted images. But when the object is very near, only then we get virtual and erect images. Whereas in case of convex mirror, we always get virtual and erect images irrespective of the position. So therefore, it clearly shows that here we are talking about a convex mirror, right? So it also asks you to draw a ray diagram. So you can draw a ray diagram like this. Write one use of such mirror and why. So convex mirror is used in the rear view mirrors in car. Why? Because these mirrors, they give a wider view of a particular place, right? So wherever we need a wider view, for example, when a person is driving the car, so with the rear view mirror, he wants to get the entire picture of the traffic behind his car, right? So therefore he need diminished images, right? He doesn't need magnified images. So therefore, in all such scenarios where you need a bigger view of a particular location, so bigger view, that means you need smaller images so that you can get a bigger field of view. So that's the reason convex mirrors are used there. Define radius of curvature of spherical mirrors. Find the nature and focal length of a spherical mirror whose radius of curvature is plus 24. So radius of curvature is basically the radius. So if you remember, what are these spherical mirrors? These are basically part of a sphere. So just think of a ball,
which is a sphere. So if I cut the ball from somewhere here, so we are left with a piece of the ball, and that piece is what the spherical mirror looks like. So radius of curvature is basically the radius of this sphere of which the mirror is a part. Now, if we are given that the radius of curvature is plus 24 centimeter, now we know that focal length is always half of the radius of curvature. So that means the focal length will be 12 centimeter. Now, focal length is positive. That means it is which type of mirror? It is a convex mirror. So if you look at it, this is the convex mirror. So the center of curvature and the focal length, they are on the right hand side. So as per sign convention, the focal length is positive. Whereas if I talk about a concave mirror, which is like this, so the focal length will be on this side. So therefore, in case of a concave mirror, the focal length is negative. Question number 2. You have two lenses X and Y of focal lengths plus 10 cm and minus 10 cm respectively. State the nature and power of each lens. Okay. So we have these two lenses X and Y. For X, the focal length is positive, and for Y, the focal length is negative. So which type of lens is X? Focal length is positive, so this is a convex lens. So here we are talking about lens. Please focus on that, because sometimes children get confused between mirror and lens, because had we been talking about mirror in this case, then focal length positive would have meant concave mirror, right? Now focal length negative, so that would be concave lens. Now we have to calculate power. So power is 1 by focal length. So 1 by 10, but if we have to write it in terms of diopter, then this needs to be converted into meter. So 1 by 10 centimeter. So this you multiply by 100, because 10 divided by 100 is into meters. So if 10 centimeter needs to be converted into meter, then we will divide 10 by 100. So then this becomes 10 diopter. In case of the concave lens, the power will be equal to again 1 by focal length. So minus 1 by 10 divided by 100. So that 100 will go to the numerator. So this would be minus 10 diopter. Which of the two lenses will form a virtual and magnified image of an object placed 8 cm from the lens? Draw a ray diagram to justify your answer. So that would happen with a convex lens, because in case of convex lens, if you see, focal length is 10 centimeter. Object is placed at 8 centimeter. That means the object is placed somewhere between the optical center and the focus. Now we know that for a convex lens, if the object is placed beyond the focal length, then the image formed is real and inverted. But if the object is very close, as in if it is between optical center and focal length, in that case we get a virtual, erect and magnified image. So here are a few questions for you to try on your own. What is dispersion? Which color of light deviates more on passing through a prism? When two prisms are placed together with one inverted and white light is passed, what will be the result? An object is placed at a distance of 30 cm from a concave lens of focal length 15 cm. List 4 characteristics of the image formed by the lens. Now see, these are directly ray diagram based questions. So my advice would be that please be thorough with ray diagrams, both for spherical mirrors as well as lenses. Now similar questions can be asked even for lenses, as in an object for mirrors. An object is placed at a distance of 20 cm from the pole of a concave mirror of focal length 10 cm. What is the distance of the image formed?
Chapter number 2, Human Eye and Colourful World. This is again a very important lesson. Now, the roughly weightage for this lesson would be around 6 to 7 marks. Now, this lesson has just 2-3 important areas, and if you have covered them really well, I'm sure you'll be able to answer all the questions from this lesson. So, the first important area is parts and functions of the eye. So, be thorough with the diagram of the human eye, each part and their functions. Second area is defects of eye. What are the eye defects? What are their causes and what are their corrections? And also be clear with the diagrams. So I think with that you will have a detailed idea of this lesson. Besides that, we also talk about refraction by prism in this lesson, which is again quite an important topic, because many a times you get a 3-marker question, or 1 or 2 marks question can also come from that topic. So dispersion, scattering of light. So these are some of the topics which are related to prisms, and you should be thorough with them. Now we will take a look at some of the questions.
Question number 1. Draw a neat diagram to show the refraction of a light ray through a glass prism and label on it the angle of incidence and angle of deviation. So this is how refraction takes place through a prism. As we all know, this is the incident ray. So as it reaches the interface AB, it undergoes refraction. This is the refracted ray. So this one is the refracted. So I'll just write. So this one is the incident ray, and then this is the refracted ray, and finally this one which comes out of the prism again after refraction is the emergent ray, and the angle which is made between the emergent ray and the incident ray is the angle of deviation, because this angle tells us that finally how much the output ray, which is the emergent ray, deviated from the original incident ray. Question number 2. A person wants to read a book placed at 20 centimeter, whereas near point of his eye is 30 centimeter. Calculate the power of the lens required. So in this case, the person wants to read a book and the location of the book is 20 centimeter. So distance of the object is minus 20 centimeter, because the object is located on the left hand side. Now near point of his eye is 30 centimeter. That means based on the ability of his eyes, the image can be formed only at 30 centimeter. So that means V is minus 30 centimeter. Now what should be, now the only thing that we can adjust to make this happen is the focal length. Correct? Because object distance is fixed, image distance is fixed. So the only thing that can change is the focal length of the lens. Now using the lens formula, we can say 1 by V minus 1 by U is equal to 1 by F. So 1 by F will be equal to minus 1 by 30 minus 1 by minus 20. So this will be equal to minus 20 into minus 30 divided by minus 20 plus 30, which is equal to 60 centimeters. So this would be the focal length. Therefore power is equal to 1 by F, that is 1 by 60, but we need to convert it into meters. So therefore this is 1.67 diopter. So this would be the power of the lens. Now here are a few questions for you to try again. What is Tyndall effect? What is its cause? Explain 2 daily life phenomenon based on this. What is scattering of light? Astronauts observe sky as dark instead of blue. Why? Give 3 differences between myopia and hypermetropia. What is myopia? State the 2 causes of myopia with the help of labeled ray diagram, and show the eye defect myopia, correction of myopia using a lens. Why is normal eye unable to focus on an object placed within 10 centimeter from the light? Give reasons. Reason behind 2 minutes early sunrise and 2 minutes early sunset. Stars twinkle but planets do not. Sun appears more reddish during sunrise and sunset. Now these type of reasoning questions are very common from this lesson on refraction, because a lot of this natural phenomenon happen because of refraction. So be clear with the understanding.
Chapter number 3, electricity. This is also a moderately important lesson. To be honest, when we did the analysis of the previous year's question papers, since this lesson has not been a part of the syllabus throughout, therefore the number of questions that we could analyze for this particular chapter was just for the last 2 years, and we could see that you actually get decent number of questions from this lesson. In fact, this is a chapter which is very important from numerical perspective. So you can get numerical problems based on Ohm's law, based on finding equivalent resistance of circuits. Be clear with the circuit related questions. You may be asked to find out potential difference across a resistor, current flowing through a circuit, and things like that. So a bit of practice on the numerical end would help, and also be clear with the formula that we use generally for finding out current or voltage or equivalent resistances. Last but not the least, electric power and heating effects of current. These are also important, but sometimes we tend to miss them. But do not miss them, because we do get questions from them as well. So overall, this lesson on electricity is a more conceptual lesson. So if you are clear with the concepts of the electric circuits, I think you'll be good to go. Roughly, the weightage for this lesson is around 6 to 7 marks, which is quite a good weightage. So therefore, be clear with the concepts, and hereafter we will take a look at some of the questions.
Question number 1. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistors, 8 ohm resistor and a 12 ohm resistor, and a plug key all connected in series. Calculate the potential difference across 12 ohm resistor. So we have drawn this diagram. It was a simple one. Now we have to calculate the potential difference across this particular resistor. Now, since these three resistors are in series, therefore the amount of current I flowing through each one of them would be the same. Now, if we know how much current is flowing across this 12 ohm resistors, and we already know that the resistance is 12 ohm, so we can easily calculate the value of potential difference, right? So our step 1 would be to calculate the value of current. So current flowing through the circuit would be equal to the potential difference, like the EMF, which is 6 volts, divided by the equivalent resistance. Now since here 3 resistors are in series, so equivalent resistance would be the sum of the 3 resistances. So this is equal to 6 by 25 ampere. Now we can say that potential difference across 12 ohm resistor will be equal to I into R. So this is equal to 2.88 volts. So we again have a couple of questions for you to try on your own. On what factors do the resistance of a conductor depend? How much energy is given to each coulomb of charge passing through a 6 volt battery? An electric lamp of 100 ohm, a toaster of resistance 0.50 ohms and a water filter of resistance 500 ohms are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all the 3 appliances, and what is the current through it? Why does the cord of an electric heater glow while the heating element does? So now here in this lesson, particularly electricity, the numericals are also quite important. So please do practice them.
Chapter number 4, magnetic effects of current. So if I have to talk about the weightage of this lesson, it is around 4 to 5 marks. So that ways it is not a very important lesson, but yes, it is a moderately important lesson. Now what happens is sometimes you may get just one question from this lesson, but that question carries 5 marks. Now, we do not want to miss a 5 marker, right? So generally these 5 markers come from topics like electric motor, electric generator, their principles, their working, their construction and things like that. So therefore these are 2 important topics that you should not miss at all. Besides that, there are other topics from where you may get a 2 marker or a 3 marker or even 1 markers. For example, the Fleming's rule. Besides that, you also tend to get 2 marker or 3 marker questions related to circular loop, solenoid or current carrying conductor. Not only that, the concept of electromagnetic induction. From there also you may get like short answer questions. In fact, the properties of magnetic field lines, that is an important topic for 1 marker questions.
So here are few sample questions for you from magnetic effects of current. State the principle of electric generator. Draw a well-labeled diagram. Describe difference between AC and DC generator in design. So these type of questions are generally asked in a 5 marker. That's what I was telling just now, right? So from this chapter, especially generator, electric motor, they are important. With the help of a labeled circuit diagram, describe an activity to illustrate the pattern of the magnetic field lines around a straight current carrying long conducting wire. Name the rule that is used to find the direction of magnetic field associated with a current carrying conductor. Is there a similar magnetic field produced around a thin beam of moving alpha particles and neutrons? Justify your answer. Question number 3, what is earthing? Why should electric appliances be earthed? Distinguish between a solenoid and a bar magnet. Draw the magnetic lines for both. What is electromagnetic induction? Explain how the movement of magnet towards or away from a coil carrying a galvanometer produce current. Write the rule to find the direction of current in this above given coil.
The last chapter that we are going to discuss in this video is sources of energy. Now this is a low priority lesson, the weightage being 2 to 3 marks. So you may expect 1 or 2 questions from this lesson, and the most important topic of this lesson are the renewable and non-renewable sources of energy. So their examples, what are they, or the difference between. So basically just focus on this topic a little more compared to others. However, we'll also give you some sample questions for your practice.
Once again, we have few sample questions from this lesson. Question number 1, why is there a need to harness non-conventional sources of energy? Give 2 main reasons. What is biogas? How is it obtained from biomass? Why is biogas considered an ideal fuel? What are the good sources of energy? Why is there so much emphasis on changing over from petrol or diesel driven automobiles to CNG driven vehicles? What is the use of black painted surface in a solar cooker? List any 4 characteristics of biogas on account of which it is considered an ideal fuel.
I hope you found this video useful. So do not miss any of the topics or any of the questions that we discussed in this video. If you are looking out for solutions for the questions that we gave out just now, please refer to the link in the description section for the detailed solutions. I wish you guys all the very best for your preparation for class 10 science board exams.